Yes. Hi dear students, we are discussing about properties of inverse trigonometric functions. In the first video we discussed about the basic graphs of the inverse trigonometric functions as well as its original functions graphs. Okay. So now let us discuss about inverse trigonometric functions properties. See the first property, sin inverse of 1 by x is always same like cosec inverse of 1 by x. So let us quick do this solution for this. What we do, we take this function, or you can take this also, no problem. Let us we take sin inverse of 1 by x equal to 1. Let us you take sin inverse of 1 by x equal to y. Then what you can say here, take this sin to original position. I told it is a inverse function. You can write it as sin y. Okay. And also my dear students, sin raised to minus 1 is not minus 1. It is inverse. Minus 1 is different. It is a notation here. We are using symbol. So 1 by x equal to sin y. But you know very well what is sin y, which is equal to 1 divided by cosec y. Correct? 1 divided by cosec y. So now 1 by x equal to 1 by cosec y. Take the reciprocal. You can say x equal to cosec y. Correct? X equal to cosec y. Then if I take cosec to the left side, it will be cosec inverse of x equal to y. Correct? Actually what is y? Y is nothing but sin inverse of 1 by x. So therefore you can say cosec inverse of x equal to sin inverse of 1 by x. This is our first property. My dear students, remember always cosec inverse of x is always sin inverse of 1 by x. Whatever the value you have here, it will be reverse reciprocal in case of the cosec inverse. Okay, that also you remember. And we go for the second property, which is tan inverse of 1 by x equal to. Can you guess? Yeah, you are right. Tan inverse of 1 by x is its reciprocal cot inverse of x. This cannot be forgettable. Easily you can write the answer for this one. So here the condition is x must be always positive. Yes? Yeah. This is you are always 100% right what you are saying. Right? Now look at the third one. Cos inverse of 1 by x, which is equal to sec inverse of x. Same. X is more than or equal to 1 and less than or equal to minus 1. Yes, this you have to remember. These are again same three set of properties, and these groups also exactly so. Tan inverse of 1 by x, take y, take tan to the right side, tan can be written as cot, and then take reciprocal, and then go it again inverse form. So it's a very simple, very easily you can write the answer for this. Okay, so this is our first set. And the property number 4. Property number 4. Sin inverse of minus x is always equal to minus into sin inverse of x. Sin inverse of minus x equal to minus into sin inverse of x. Lekin x must be in between minus 1 to plus 1. Otherwise it cannot be valid. Take this point. हमने डोमेन पढ़ा है इसका, डोमेन रेंज. Yes, what is the value for this one? It should be in between minus 1 to plus 1. Yeah. Now look at this. Solution for this part also the same. What I do? I will put sin inverse of minus x equal to, again let sin inverse of minus x equal to, I will take it as 1. What exactly this one? It is minus x equal to sin y. What about this? It is all nothing but I am interested in. What I am interested? Minus into sin inverse of x. Correct? You get my point? Multiply minus. So you get x equal to minus into sin y. See, we are talking about the inverse trigonometric function. But basically we know your trigonometrical functions. See, sine of minus theta, fourth quadrant, it is always minus sin theta. Last year you learned in the P1. साइन ऑफ माइनस थीटा इज माइनस साइन थीटा. अभी माइनस साइन y है, इसको हम क्या लिख सकते हैं? साइन ऑफ माइनस y. करेक्ट? I am interested in sine inverse of x. Take this sign here. You get it as sine inverse of x equal to minus 1. What exactly? Y? This one, but multiply minus on both sides. You get minus into sine inverse of x equal to y. But what is y? Y is nothing but sine inverse of minus x. Sine inverse of minus x. Yes, my dear students, remember this. It's a very easy formula to prove this. Generally, these questions will ask for 2 marks. What is that? Sine inverse of minus x. Fourth property we are talking. Sine inverse of minus x is always minus into sine inverse of x. But एक बात तो याद रखना होगा, x must be in between -1 to +1. Correct? Yes. Now I will go to the next property number 5. Yes, I hope you can only guess what is the property number 5. Yes, what is the property number 5? Tan inverse of minus x. Tan inverse of minus x. It is also minus tan inverse of x. Remember, tan inverse of minus x is always minus x. आपको डोमेन पता है, any real number. X may be any real number. So here also not necessarily exactly the same proof. And sixth one, cosec inverse of minus x, which is, you can say, minus cosec inverse of x. And you know very well the domain of the cosec is mod x is always greater than or equal to 1. We can say mod x is greater than or equal to 1, or else you can say it is x is less than or equal to -1 and greater than or equal to +1, and x is more than or equal to +1. See, this fourth property, fifth property and sixth property all are same. That's why I have written only the proof of fourth one. Fifth and sixth exactly the same. Take this value and do the same process. You get the answer of this one. But I have removed. I have not written the cos inverse function, cot inverse function, and sec inverse. Why? Look at this. You will enjoy this. It is cos inverse of minus x. It cannot be minus cos inverse of x. It is pi minus cos inverse of x. What about this? It is pi minus cos inverse of x. Wow, what is wonderful it is. So x belongs to -1 to +1 ही होना है. X has to be in between -1 to +1. Solution for this. What is the solution for this? Take the first one. Let cos inverse of minus x का value होगा y. Correct? Take this cos inverse to the right side. You get minus x equal to cos y. Yes, but what you are doing right here? Pi minus cos inverse of x. Yes, you can understand very properly. Are you getting my point? Okay. Multiply minus on both sides. X equal to minus into cos y. Where the cos is negative, understand properly. ASTC. Where the cos is negative इन दोनों में से 180 minus 180 plus 180 minus 180 plus. So 180 minus, why should I take? 180 plus, why should not I take? Because cos का जो डोमेन है 0 to pi. अगर आपने 0 pi plus लिया, if you take 180 plus, then it will be wrong. Correct? Why? It goes beyond the domain of the function. So for that, I will take it as cos of pi minus of y, not pi plus. Concentrate on the domain. It's very important. Now, it is cos inverse of x equal to pi minus 1. Yes? But what about pi? Oh, sorry, y? Cos inverse of minus x. So what I do here? I will take minus y to the left side and cos inverse to the right side. Minus y equal to pi minus cos inverse of x. What I have done? I have taken y to the left, cos inverse to the right. But exactly what is y? Cos inverse of minus x. Cos inverse of minus x equal to pi minus cos inverse of x. Yes, my dear students, I hope you can understand this one. Very easy problem, very easy property it is. Aram se you can do this. Yes. Now I will definitely go to the property number 8, but I don't solve that. You know very well why? Because exactly same like this one. What are the properties? Property number 8. What is that? Sec inverse of minus x, which is pi minus sec inverse of x. What is the value of x? Mod x is more than or equal to 1. And ninth one, what is the remaining? Cot inverse of minus x. This is pi minus cot inverse of x, where x is any real number. This is what we have to remember. Okay? Yeah. I hope you have enjoyed these properties, very simple properties of this one. Correct? Now I will go to again very important properties. 10th property. Still many times we use this. Sin inverse of x plus cos inverse of x is always pi by 2. Sin inverse of x plus cos inverse of x is always pi by 2. Whereas x must be in between -1 to +1. Otherwise ये नहीं हो सकता है. अगर आपके पास x और y sin inverse of some number cos inverse of some number cannot be pi by 2. Sin inverse of cos inverse of जो values है, given values है, these values cannot be more than +1, less than -1. That also you can remember. Solution for this. What is this? Yeah, let you can say sin inverse of x equal to y. See, my dear students, what I am doing here is simply every case I am doing the same property, same proof. Okay, sin inverse of x equal to y. Take this sin inverse to the right side, means make it original form sin y. So x equal to sin y. Now look at this. X equal to sin y I got. Exactly I am interested in cos. Correct? You know very well. Last year we learned allied angles. Cos of 90 minus theta. Cos 90 minus theta is always sin theta. Cos of 90 minus theta or pi by 2 minus theta is always sin theta. What about this one? You can say cos of pi by 2 minus y. Correct? Cos 90 minus theta, sin theta. 90 to 70. 90 to 70. Always trigonometric function changes. 180, 360, trigonometric function remains same. Understand? Yeah. Now take this cos here. You get cos inverse of x equal to pi by 2 minus y. I am not interested to keep y here because I want y to the left side. I take y to the left. So y plus cos inverse of x equal to pi by 2. What exactly y? Sin inverse of x. So sin inverse of x plus cos inverse of x equal to pi by 2. Yes. This is what the next proof. Sin inverse of x plus cos inverse of x is always pi by 2. Understand properly. Look at this. Sin inverse of x plus cos inverse of x is pi by 2. Yeah, very good. So the next one, very again important, and the similar properties I am proving. It is property number 11. What is that? Tan inverse of x plus cot inverse of x equal to pi by 2. You know what I'm going to do. I am not solving this. Why? Same. अभी हमने डायरेक्टली tan inverse of x equal to y लिया, बाद में tan inverse उसको tan y लिखा, बाद में tan becomes cot 90 minus theta, बाद में reverse inverse pi. Then it's very simple. Similarly, again, what is that? Sec inverse of x plus cosec inverse of x, which is equal to pi by 2. Sec inverse of x plus cosec inverse of x equal to pi by 2. Sorry, इसमें तो x का value कौन भी हो सकता है. You can take any value for this. Here x is mod x is greater than 1. Mod x का meaning, mod x meaning x is smaller than -1 and x is also more than +1. This is what these three are the next properties. So remember, my dear students, these are very important properties. And the next one, 13th property, what I am proving. I am not proving this property, it is obvious case. Why? Look at this. Sin inverse of x. Sin inverse of x is always x. Where whenever x belongs to the -1, closed interval -1 to +1. And 14th one, f of f inverse of x is x. Similarly, cos inverse of x, which is again x. Similarly, x belongs to -1 to +1. And 15th one, tan inverse of x. What is this? It is x. X is any real number. This is how we can write. And the next one, reverse. First inverse, then next. Sin inverse of sin theta. Sin inverse of sin theta is theta. लेकिन theta तो -π/2 से +π/2 में होगा. Theta must be in between -π/2 to +π/2. Cos inverse of cos theta. This is cos theta. Only theta. Theta must be in between 0 to pi. 18th one, tan inverse of tan theta. This is theta. What about this? Theta is -π/2 to +π/2. Understand my point? I hope you enjoyed this session also about the properties. Yes. Next, we will again go to the very important again. You can say problems here as well as the properties. Two properties are remaining. Tan inverse of x plus tan inverse of y equal to again, which is tan inverse of x plus y by 1 minus x square. Very important result it is. Every year 3 times it is asking question. So this is about the second video. In the third video, I hope you can wait and you can see that. Remember my dear students, don't forget subscribe the channel, because other college students are getting the benefit, you also get. Everyone are getting the benefit. Okay. Everyone are getting the benefit. Everyone are getting benefit. You also get the benefit of this. And subscribe the channel. You want very important videos for the revision. You want very important revision for the basic knowledge. So detailed what the NCERT is there, we are solving that, and we'll give very easy methods to solve them. And just go and subscribe the channel of this one. Okay. Yes. All the best. Thank you.